All right, hi folks, I'm recording a video for section 7.1, and 7.1 has to do with working with inverse functions. So this involves inverse sine, inverse cosine, and inverse tangent. So let me give you an example what we're asking about when we talk about inverse functions. So let me give you a quick example. Let's say I take the sine of an angle like 30 degrees. Well, you might remember the sine of 30 degrees is 1/2. Remember, I can also write this in radians, and I could write the same equation as the sine of pi over 6 radians equals 1/2. Okay? Now, inverse sine, we write with this, what looks like an exponent of -1. It's not really an exponent. It's a special notation that means we want the inverse sine of a certain value. I'll call it x. So what inverse sine is asking you is find the angle x. And let me give you an example. Let's say I said inverse sine of x equals 1/2. I'm sorry, I'm going to say the inverse sine of 1/2 equals question mark. Actually, let me rewrite this to make this a little clearer. Let me restart here. So I want to write this as the inverse sine of some value. Now the answer I get from this inverse sine function is an angle. So our answer here is an angle. Okay, so if I was to ask you, what is the inverse sine of 1/2? Well, really that's asking you the question, what angle has its sine equal to 1/2? Well, the answer here would be, I could either write it as 30 degrees, if I wanted to write the answer in degrees, or I could also write the answer here as pi over 6. All right, so inverse sine is really asking you a question where you're given a value, like a numeric value, and you're asked to find the angle. Notice that's the opposite of taking the sine of an angle and getting a numeric value. So we're really working backwards in a sense to undo the sine function. All right, well, there's one special consideration for inverse sine though. For inverse sine, your answer, the angle, remember the angle is really the answer, must be in a very certain interval. And that interval is in the interval from -90 degrees to +90 degrees. I could write that as -pi over 2 radians to +pi over 2 radians. So anytime you come up with an answer for an inverse sine, your answer must be in this interval. Okay? All right, now on the right side here, I have some tables from section 7.1 that's going to make this a little easier. I could use the unit circle to help us out here, or I could use these tables. So let's go to this question here. It says, what is the inverse sine of 0? So inverse sine of 0. And again, what this question is asking you is, what angle has its sine equal to 0? So what angle has sine of 0? Okay. Well, I can come here and look up using this table because I'm noticing the sine of 0 corresponds to an angle of 0. So in this example, the angle here, or the answer, should be 0. And I'm going to enter answers here in radians. because I'm noticing it says using pi as needed, so that indicates that we want to use radians as the answer. Okay, let's go ahead and do another example. Here's cosine inverse of 1. Now, cosine inverse is really the same kind of setup where we're being asked what angle has its cosine equal to 1. But for inverse cosine questions, so for cosine inverse of a numeric value, your answer, and remember your answer here is an angle, must be in a certain interval. And for inverse cosine, the interval is from 0 to 180 degrees. And I can also write that in radians. It would be 0 to pi radians. You might remember 180 degrees is the same as pi radians. So any answer I come up with has to be an angle between 0 and pi radians. All right, and remember for inverse cosine, we're really looking for an answer that's an angle. So my answer is really going to come from this column that's labeled as theta. All right, well, I want to know where is the cosine equal to 1? Well, you might notice right here the cosine is 1 when the angle is 0. So the answer to this question is going to be 0. All right, let's do a few more. I'm going to jump to some examples that are a little different. Well, let's come here to tangent. So this is inverse tangent of 0. So for inverse tangent, again, there's a certain interval that's allowed for your answer. And for inverse tangent, the answer, and remember your answer here is going to be an angle, must be in the same interval as the sine was. So the interval here is negative pi over 2 to positive pi over 2. By the way, you can kind of see that from these tables in section 7.1. Notice the angles here for the sine, inverse sine, are only going from negative pi over 2 to positive pi over 2. And notice for cosine, the angle is only going from 0 to pi. And for tangent, it's going from negative pi over 2 to pi over 2. All right, so by looking at these tables, it gives you an idea of the allowed interval for your answer. All right, well, they're giving us here the inverse tangent of 0. So I'm going to know what angle has its tangent of 0. Well, here's the tangent of 0. That angle is the angle 0 radians or 0 degrees. So again, for this one, the answer is going to be 0. All right, let me jump ahead so we could do a few more examples. Let's come to this one. This one says inverse sine of square root of 2 over 2. So I'm looking for an angle. So really what this question is asking me is find the angle, I'll call it theta, find the angle theta such that the sine of theta is equal to the square root of 2 over 2. And remember, my answer must be an angle between negative pi over 2 and pi over 2. That's the only allowed interval that I could use for inverse sine. Well, what I'm going to do is come over to this lookup table here, and I'm noticing here is the sine of an angle equals square root of 2 over 2. Well, what's the corresponding angle? Well, theta is pi over 4. So the answer to this question is going to be pi over 4. And you might remember when you click your mouse in the answer box, you get this menu on the bottom. So I'm going to click this fraction button. And on the top of the fraction, I'm going to put pi. And on the bottom of the fraction, I'll put 4. Okay. All right, let's do 1 or 2 more. Let's go here. This one says inverse tangent of inverse tangent of square root of 3 over 3. All right, well, this question is really asking me to find the angle theta such that the tangent of theta is equal to square root of 3 over 3. All right, let me come over here to table 3, which gives me different values of tangent for different angles. Well, I want to know, where is the tangent equals square root of 3 over 3? Well, noticing it's right here on this table. What angle does that correspond to? Well, you can see the angle theta is pi over 6 in this example. So my answer to this question is going to be pi over 6. Again, I'll enter a fraction, put pi on top, and 6 on the bottom. All right, let's do maybe one more example. By the way, you can see how handy these tables are. So please keep these tables with you. These tables are given to you in section 7.1. All right, let me go to this example. It says inverse sine of negative square root of 3 over 2. All right, well, again, what this question is asking me is find the angle theta such that the sine of this angle theta is negative square root of 3 over 2. And remember, my only allowed answer has to be in the interval from negative pi over 2 to positive pi over 2. Well, I'm going to go to table 1, and I'm going to look up, where is the sine equal to negative square root of 3 over 2? Well, here it is right here. What angle does that go with? Well, the angle theta here looks like it's negative pi over 3. So the answer to this question is going to be negative pi over 3. So let me come here. I'll enter a fraction, and I'll make this negative pi over 3. All right, folks, hope this is helpful as you're getting started in the Section 7.1 homework.